Okay, hi guys. All right, last video hopefully for this unit. As part of your homework before watching this video, please make sure you do use your phone. Text that number with the message at symbol DeBold AP. What it is it's a way for me to send you guys messages and reminders. So what this video is going to do is it's going to go along with how to find the minimum sample size. Reminder, our test is on Friday and I'm after school Monday and Wednesday of this week. So just a refresher of what we're looking at on our formula page. Standardized test statistic means your z-score. We usually say this as value minus mean over standard deviation. A confidence interval is what we've been doing. Confidence interval we use to estimate something. So it's our statistic. For a statistic, you have two options, x bar or p hat. Okay, and so it's your statistic, one of these two things, x bar or p hat, plus or minus. So it's your sixth statistic, x bar or p hat, plus or minus your critical value times the standard deviation. Now, if it's the mean, the standard deviation is sigma over the square root of n. If you're talking about proportions, it's the square root of p times 1 minus p over n. Okay, and a reminder, on your formula page, this give and take, this plus or minus, it's your margin of error. Okay, so your margin of error is not given to you in words. So this is the margin of error for proportions, and this is the margin of error for means. Again, this is part of your formula page as well. The confidence level, this is each of these are your critical values for proportions. Okay, so this is what you're given, and what we've done a lot of this unit is just made confidence intervals. We're 95% confident that the average height of a student is between blank and blank. What we're going to look at today is a type of question, and if you remember what we did where bias is rife and the bigger sample size is usually better, okay, that article that we read a couple weeks ago, the real world article, is we're going to look at situations where how do you know how many people to sample? How do you know how many people you need to sample and what size is a good sample size? Because we look at all different types. We look at studies with hundreds or thousands of people, and we also look at studies where there's only 30. Like for means, we say 30 is okay. So here we go. A researcher wants to try to estimate the percent of Americans who use a cell phone. So they want to know P is the percent who use a cell phone. They want to figure out what that percentage is. They don't know it. They're trying to estimate it. So usually we make an interval to estimate that. The results were as follows. We're 95% confident that the true population proportion of cell phone users lies within 3% of 88%. So we've read this before. So our confidence level is 95%. That tells us that our critical value, which is our z-score, if we go back to the chart on the front of your page, if you look at this chart for 95% confidence, this was our critical value, 1.96. Lies within 3%, so our margin of error is 3%, whereas a decimal, 0.03, of 88%. So that's our p hat, 3% of 88%, and that's how they got. You can actually make the interval. The interval would be 88 plus 3% and 88 minus 3%. So the interval would be from 85% to 91% of people have a cell phone. The question here, though, is asking us, what was the sample size used? What was the sample size used? Okay, so if we want to do that based off what we have a z, our critical value, we have the margin of error, and we have the p hat. So what do we have linking these three things? The only thing we have linking these three things is our margin of error formula, this margin of error formula for proportions. So margin of error for proportions is your critical value times the standard deviation, p times 1 minus p over n. We are going to try to solve for n. That's what we're going to try to solve for. So what we're going to do is we're going to plug in everything we can. I'm going to just move this down. We're going to plug in everything we can and solve. Okay, so our margin of error, we have 0.03 equals 1.96 square root 0.88. 1 minus 0.88 is 0.12. all over n, and we're trying to solve for n. So there's a couple ways you can do this using algebra, and yes, we are going to use algebra. One of the things you can do is say, okay, I want to get rid of this square root, so I'm going to square both sides of my equation. So if I square this, I get 0.0009. The square sort of is distributed to both things. So 1.96 squared is 3.8416. This square is going to cancel out with that square root. So in my calculator, 0.88 times 0.12 is 0.1056 over n. Now I'm still trying to figure out what n is. So I have 0.009 equals, I'm going to multiply these two numbers together. And so let's see what that would be in my calculator. 3.416 times 0.1056. Okay, so I get this long decimal of 0.40567296 over n. I still want to try to figure out what n is. So if I put this over 1, I can cross multiply. I get 0.0009 n equals that 0.4056. To get n by itself, divide both sides. And let's see what we get. So in my calculator again, I'm going to take that number that I already have in there and I'm going to divide it by 0.0009. Okay, so I get 450.74773333. Okay, so we were asked what sample size. Well, that cannot be a sample size. That's only like part of a person. So to make it a whole person, we need to say, okay, this 450 would become 451 people. So we have to round up because we know that they had 0.7 of a person, meaning they must have had a full person. So what this is a way for us to say, let's choose our sample size. What sample size? So in general, the sample size needed to produce a confidence interval with a given margin of error. So what that means is they will give you the margin of error at a given confidence level. So the margin of error is going to be given. The confidence level will be given. And you are going to find n. So to do this, what you're doing is you're using your margin of error formula. It's your critical value times the standard deviation of the statistic. For proportions, that means the margin of error is your z from the chart times the square root of p times 1 minus p over n. And you're going to have to do some algebra to solve for n. As a reminder, to be safe, we always round up. Remember, if we have only a fraction of a person, we need to complete that person, so we're rounding up, no matter what the decimal is, no matter what, even if it's not above 0.5. Okay, so let's look at one more example. What if this is the first study of its kind and we don't have a p-hat? So in the previous one, we already knew, okay, 88% of some sample had a cell phone. In this one, what if we don't have that? So a politician wants to know what percent of voters support her proposition on the issue of universal pre-K classes being funded with taxpayers' money. What size voter sample, so that's how I know they're asking us for the sample size, what size voter sample should be obtained to determine 90% confidence? Okay, so let's start writing them down. 90% confidence level tells us, flip your page over, that your z is going to be, if you flip your page over, 90% confidence, 1.645. So that's the confidence level. To support within 4%, that means within 4%, that's my margin of error, 0.04. So the two numbers we're given are those, and I still want to know what sample size. So what this means is she has no other previous study to base this off of. She has no idea what percent of people would actually agree with this. So in general, if we have a simple random sample, we know we always want randomness, and an estimate for the proportion, we can use the sample. We want to estimate, the population proportion, then we use the sample proportion. If we do not have a sample proportion, because this is the very first study of its kind, we want to assume, like in this one, the percent that will support and not support are equal. So if the percent that will support and not support and not support are equal, that means we're going to use p hat equals 0.5 or 50%. Okay, because that's unbiased. It's not swinging in one direction or the other. This way the sample is not pulled in either direction. Because remember, this is a binomial situation. We have two options here. Do support or don't support. Okay. We assume that the success and failures are equally likely. Okay. So a little rhyme to help you. If we know P, use P hat. Or sorry, if we know P, use P. P is the best. It's the population. That's always the best. If you don't know P, use P hat. This is what we do for confidence intervals. If we don't know P hat even, we use 0.5 to be unbiased and keep things equally likely. So to actually solve this question above, if I was actually to solve it using my margin of error formula, and I want you to try to finish this one, my margin of error I know is 4%. My Z is 1.645. I don't have a P hat, so I'm going to have to use 0.5 and 0.5. What I want you to do is try to solve this right now. So you can pause the video, try to solve it. And what you should end up getting is 422.82, which tells you you would need 423 voters is how many she would have to actually sample. Okay. So again, our test is on Friday this week. Please make sure you go through this video, go back over it and any of the other previous videos. I will see you in class. Enjoy your day off.